Hi there, I'm Yixue Zhao from University of Southern California. In this video, I'll be presenting our work FrUITeR, a framework for evaluating UI test reuse. This is a joint work across University of Southern California, Columbia University, and University College London. So first of all, what is UI test reuse? I might be biased, but I think it's a new and a very exciting research area to work on right now. It refers to a type of test generation technique that can automatically generate usage-based tests. Usage-based test is a term that you can find more details in our paper, but basically it is a test case that can test an app's functionality, such as sign in as shown in this diagram. So the idea is, given some existing test cases of a source app, I can automatically generate new tests for a new app by mapping the similar UI elements. So in this example, I can generate B31, B32, B33 for the target app automatically by reusing an existing test case A11, A12, A13 by mapping the similar UI elements. But why do we need an evaluation framework? The idea sounds pretty neat. Why don't we just propose a fancy technique? So that was what I was thinking earlier last year when I was doing my thesis proposal. I thought this idea is really cool. I want to propose a fancy technique about it. But it turned out I was not the only one. There were already very few work on this area and in the very, very recent time period. And also at the same time, earlier last year, there were people who improved upon existing work and submitted their paper at that time. And both papers later got accepted at ASE conference last year. So that's why FrUITeR was born, because if I want to have my new fancy technique, I now, since there's already existing techniques, I want to first identify the limitations of the state of the art. And then I can see which techniques are better so that I can compete my technique with them so that I can show that my technique is better. Well, it turned out that proposing and developing such a framework to evaluating existing test reuse techniques is really hard. That's why I did not get to propose a new fancy technique, but I spent all my time to develop this framework. So today I will give you some taste of why it is so challenging. We first identified 5 key challenges to develop this framework, then establish the 5 key requirements that should be addressed. You got to do it in a software engineering way, right? And then we designed this FrUITeR framework to address those requirements. And of course, you need to build a benchmark so that different techniques can be evaluated on the same benchmark. By the way, they were not evaluated on the same benchmark before. So you cannot see which one is better just by the results from the original papers. And in the end, with this FrUITeR framework, I also need to migrate existing techniques to FrUITeR so that we can evaluate them side by side on the same benchmark to understand their differences and similarities. In this video, I will focus on 3 out of 5 challenges that we address in FrUITeR. So first one is the evaluation metrics used by existing work are different and limited mainly because this is a very new domain, so standards are not set up yet. So the evaluation metrics they use are quite different. For example, when you see 50% in one paper, it doesn't mean the same 50% in another paper because they don't use the same metrics. And also, existing techniques focus on evaluating the accuracy of how you map the UI elements from one app to another, but accuracy metric doesn't really mean the generated test case is really good. Let me show you an example. So these are 2 shopping apps, Wish and Etsy. So if you want to transfer existing test from Wish to Etsy, then you can just map the A11, A12, A13 to B31, B32, B33, right? But assuming you map this automatically and perfectly with 100% accuracy, still you are missing some steps B11 and B21 in HC, so your test case is not perfect. And the second challenge is evaluating existing technique actually requires a significant manual effort. So in the same example, if you want to evaluate your technique that transfers tests from wish to ESEC, imagine you have one test with 3 events, like this example. Then what existing work does is you manually inspect every GUI event in this test to see if the mapping is correct or not. So in this case, you have to manually inspect 3 times to see A11, A12, A13, whether they are correct or not. And imagine you have 10 apps, then there's 100 source target app pairs, right? And for each app, imagine you have 10 tests, and each test has 10 events to map from and to. So in the end, you have to manually inspect 10,000 times. This is just not very realistic. That's also why actually in one of the papers, they restricted their comparison with prior work with only half of the app pairs. And the third challenge is there's no guidelines for this manual inspection. This will yield biased and unreproducible results, right? Because, for example, if I want to see whether my technique maps A11 correctly or not, and if my technique maps A11 to B31, do you consider it correct or not? This is actually debatable because in A11, the text says enter the email, but in B31, it actually says you can put both email or username. So if I map them, map from A11 to B31, is that correct or not? This is actually quite subjective, and currently we don't know what existing technique considered is correct or not, because there's no rigorous guidelines to show how you should do this manual inspection. Now I will show you how FrUITeR addresses the first challenge about the metrics. So if the evaluation metrics are different, the natural step is, oh, we should just standardize them. So that's exactly what we did. I contact all the authors of existing work and understand what exactly those metrics mean when they evaluated their techniques. And here's a map, which I won't go into the detail, but you can find this map in the paper as table 1. So basically, I map the different metrics used in existing work to FrUITeR's 7 fidelity metrics that focus on the accuracy of a technique using the standard name that we defined in FrUITeR. This covers all the evaluation metrics that has been used previously. And then to address the limitation of evaluation metrics, remember how we also want to measure how useful a test case is in practice, because accuracy doesn't mean good, right? So we also developed 2 utility metrics to measure that aspect. And I'll show you one example. One metric is called effort. It measures the Levenshtein distance from the transferred event to the ground truth events. Basically, it means how many steps you need to take to correct the automatically transferred event to match the ground truth event. To address challenges 2 and 3, that is the significant manual effort required and no guidelines for manual inspection, we designed the FrUITeR framework, and I'll only highlight the very high-level workflow. So first, we have the source tests which are the existing tests of the source app, and the ground truth tests that serve as the evaluation baseline, and also the transferred test cases that are transferred by an existing technique. Given those test cases, we convert them to a uniform representation by event extractor. The key to automation is to have a uniform representation so that we can automate the process, right? We also introduced the GUI maps and canonical maps with the uniform representation. And what GUI map does is it shows the mapping given by an existing technique to show how the existing technique maps the GUI events from one app to another. And the canonical maps is more complicated, and I'll discuss later with a concrete example. And then FrUITER's fidelity evaluator and utility evaluator evaluates the 7 fidelity metrics and 2 utility metrics in FrUITER and automatically generate their final results. And the detailed algorithms can be found in our paper. So as promised, here is what a canonical map is. Basically, canonical maps is something you construct manually that represents the ground truth of the GUI event mapping. And I'm showing 2 examples of the canonical maps for 2 apps, Wish and Etsy here. It maps the app-specific GUI event to a canonical event that shares a universal name across different apps, so that when you tell me how your technique maps one event to another, by looking at the canonical maps, we will be able to see whether that mapping should be considered correct or not by looking at whether they are mapped to the same canonical events, right? So as I mentioned earlier, this canonical map construction is the only manual effort that is required in FrUITER. That's how we address the challenge number 2, which is a significant manual effort. Because constructing this canonical map is a one-time effort per app, and it doesn't matter how many more test cases or events for the test cases you want to evaluate, you do not need to manually inspect them one by one, and you do not need to construct more canonical maps, since once it's done for one app, you don't need to do anything else. You can just evaluate the hell out of this app. As a comparison, previously, whenever you have a new test case or more events to evaluate for the new test cases, you have to manually inspect every single event, even for the same app, every single time. So that is not a scalable solution previously. So we don't want that. This is addressed by FrUITER. Okay, to address challenge number 3, that is the lack of guidelines for the manual inspection. It is actually also addressed by the canonical maps because now the ground truth is written in these canonical maps. For example, in this case, which we mentioned earlier, whether you map A11 to B31 is debatable, right? And if I construct my ground truth in these 2 canonical maps, it means mapping them should be considered correct since they are mapped to the same canonical events. And now, if another researcher comes in and disagree with this ground truth, they can simply modify the canonical map to have their own ground truth. For example, I consider B31 is username and mapping from A11 to B31 should be considered wrong. Then I can simply change my canonical map like this, and then have FrUITER to reproduce the results based on my ground truth automatically. So the canonical maps can be easily verified so that you can see what ground truth prior work based on. And if you disagree, you can just modify it, or you can even reuse the previous canonical maps if you are evaluating the same app, or extend it to benefit future research as well. Okay, so this is all great, but in reality, there's always more challenges because after designing and developing FrUITER, I wanted to show it also works in practice. And the way to show the usefulness of FrUITeR is to show how we can use FrUITeR to evaluate existing work, right? But the challenge here is existing works were developed before FrUITeR, and obviously they didn't follow FrUITeR's workflow. Otherwise the author could read my mind. But anyway, so because of this, I had to study the implementation of the existing work and then contact the authors so that I can understand their code and then modify the necessary parts to produce the artifacts that the FrUITeR needed as an input, then verify my modification with the authors. And also, as I mentioned earlier, all the existing work were not evaluated on the exact same benchmarks. So I also had to establish a benchmark with the same apps and the same test cases to evaluate existing techniques on, and also constructed 20 ground truth canonical maps that serve as the ground truth for the GUI event mapping. And actually, since I'm talking about it here, I wanted to give a shout out to the authors of the existing techniques. They were very responsive and helpful, which actually is not that common when you send an email to the authors to ask about their tools, right? So I consider myself pretty lucky in this case. And in the end, after all the hard effort, FrUITeR was able to generate results for 1,000 source target app pairs, and it yielded over 10,000 result entries. And each entry means the results of transfer one specific test cases from one specific source app to a specific target app using a specific technique. And each result entry shows the 7 fidelity metrics and also the 2 utility metrics we talked about. And this is just an example diagram to show FrUITeR's results. And I highlighted the 2 techniques here, perfect and naive, which were actually developed by us to serve as the evaluation baseline so that we can make sense of what do all those numbers mean when you see them for the existing techniques. I'm not going into the details, but our website contains all the detailed raw data of the final results and also how you can reuse FrUITeR or reproduce the results with instructions. So feel free to check that out. And here I will only highlight some implications out of FrUITeR's results. First, we found out that the perfect isn't perfect. Remember how we had the perfect technique that assumes you can map the GUI event perfectly with 100% accuracy, but it doesn't mean your transferred test case is perfect because you also want to consider the practical usefulness of the transferred test case. For example, sometimes you might need to add some extra steps into your transfer test case. And second, we also noticed that source app selection is a very interesting research area in the future, actually, because right now we select the app from the same category, but we saw in our dataset that some specific target source app pairs always have good results. And one such pair is, I think it's Geek and Wish. They are developed by the same app company. So that could be one way to suggest what source apps you should use to transfer events from. And another way could be using some called clone techniques to detect the similar apps so that you can yield better results to transfer the test cases from those similar apps. Of course, there can be other similarity metrics you use to select the similar apps, but that will be a good way to yield better results for the transfer. And the third one is the testing technique selection. So we noticed that there's some trade-offs between existing techniques. We classified those techniques into machine learning based and similarity based. They have their respective pros and cons. If you want to know the details, please check our paper. But given specific situations, which technique to use is actually something you should trade off, because there's no winning technique in every case. And also we noticed something interesting is this automatic transfer is not always the good thing to do, because we also measured the effort of correcting the transferred test into to match the ground truth test, and it shows sometimes to the manual effort to correct it can be even more than you just simply write the test case from scratch manually. So this shows that in the future, maybe research can consider some ways to suggest whether I should choose to write this test case manually or using some sort of automatic technique to generate, because apparently automatic is not always the way to go. Okay, all right. Thanks for watching the video. If you have any other questions, please feel free to reach out to me and check out our paper that has more details. And I also talked about more future directions in this very exciting area. And also, I talked about some of the future directions in my dissertation, which will be published soon this year, I think. So please stay tuned to connect with me so that you will get the most recent news of my work. Thank you very much.